I was asked a question by a colleague of mine at Keele about 8 years ago, and he said to me, how do we find clandestine bodies? He is a geophysicist, he's in an earth science department at Keele, and his interest is in using techniques like resistivity, conductivity, ground penetrating radar, the kinds of techniques that you see Tony Robinson and his team using on Time Team. We wanted a model for a buried body, and everybody around the world doing this type of research uses the pig. So we have buried pigs over a number of years in a variety of locations. Crime Scene House, up at Keele and around the country with other colleagues. And over the years what we've done is we've used our various techniques to monitor, to try and detect whether or not we can see their presence and how that presence changes as those bodies decompose and putrefy. Now, Jamie's interest from an earth science perspective is using ground penetrating radar and conductivity and resistivity, and it works beautifully in collaboration with us because we're interested in the chemical signature, the chemical fingerprint. When bodies decompose, they release all of the elements, fatty acids and proteins, etc., and they change the environment around them. Now, we can collect the materials that are released, we call them leachates, and we can use some of the equipment we have in this laboratory to see, was there a body there, is there still a body there, and potentially determine how long that body has been there. There has been a lot of research in America in places such as the Body Farm in Tennessee. Now, that work is fine, it's marvellous, and it's been published, but it's in America. Now, their geology, their geography, their weather, everything about it is very different. And it's essential that any research is A, repeated to test its quality, but also to see whether or not it matches our particular geology and geography and climate, etc. So for us here in the UK, it was essential, working with our colleagues at Keele, to see whether or not our data would match what we found in America and add to that. Research has fundamental importance. If a senior investigating officer in a murder inquiry or a missing persons inquiry where they believe a body has been buried sometime in the past asks, I have a field, it's a 5-acre field, where do I dig? Well, you have two choices. You can send in the JCBs and dig up thousands of tons of soil, which of course is a waste of time and resources and evidentially is very damaging. Or you can spend months looking for a site specifically with a shovel and men on their hands and knees. But that really doesn't help in terms of cost and time. What we want to do is to be able to take some small soil samples in a grid fashion, test them in the laboratory, and be able to say to the senior investigating officer of the team, here's a hotspot, or there's a hotspot. These are areas that you should perhaps concentrate your efforts on. Well, interestingly, in the laboratory, what we're already finding is more and more fingerprint signatures. We're looking for more and more individual chemicals that are present very early on in the deposition of our bodies and that last for quite some time. A short signature, short-lived signature is of no use at all. It has to be there for hundreds of days post-burial. So we're finding more signatures, more specific to man rather than just a cow having been buried or a sheep having been buried. So all of these improvements in our systems will allow us to have a more accurate, more precise body of data to offer the senior investigating officer as a body of evidence. Fundamentally, it's essential that any research that we do is trickled down into the teaching within forensic and crime science in the university. So all of the research that we conduct, we like to bring into the classroom. Here we can see some of our undergraduate forensic science students recovering a body from a clandestine burial that's resulted from the detection of that burial. So really what we have is we have gone from grave to graph, from graph to crime scene, and from crime scene to court.